In the previous video we had discussed about this frame. We had solved the end moments of this given frame. Now we will try to understand how to calculate the reaction, and then we will also discuss about shear force diagram and bending moment diagram. So in this again I am drawing the free body diagram as it is. Okay, as we know, at this joint we have 3 reaction, at joint D also we have 3 reaction, and there is 1 reaction at C. I have tried to write all the different reactions in different colors, so you can see vertical reactions are written in blue, horizontal reactions are written in red color, and then moment values are end moments are written in black color symbol. Okay, so this is your AB value, which is minus 17.81, and MDC is minus 7.186. so VA, VD, HA, HD, everything has been calculated. So we will look into these diagrams to understand how we calculated this reactions. Okay, as we know, there are 3 elements, 2 column elements and 1 beam elements. We'll take 2 column elements over here, and we'll mention all the external loads and the internal moments that are available in this given members. Okay, so let us take the member AB. Member AB is subjected to an external horizontal force which is 40 kN. Because of that, the reactions are generated which are equal to 20 and 20. Okay, next is that we will take the same element and we will apply the end moments that are observed. So the end moment here is minus 17.81 and the other one is 24.37. so we have mentioned them. According to that, we try to determine how much is the reaction. So the reaction will be 24.37 minus 17.81 divided by length is 4 meter. We will get to know it is 1.64 something. Okay, now similarly we can write how much is the reaction over here by changing the symbol and keeping the magnitude same. Okay, so once we solve for MAB, we can go for MCD. For MCD, there is no external force that is acting. So next thing is to take the same element and apply the external forces that we have observed. So the applied external forces are minus 7.186. the other one is minus 14.37. okay, I have tried to solve here the reaction that you can observe at this joint, which I am calling it as RD. Okay, so here RD into this distance is 4 meter, because I am taking the summation of all the moment at C. So RD into 4 meter minus of 7.186 minus of 14.37 is equals to 0. If I send these two terms, it will become plus. So it means what, 14.37 plus of 7.186 divided by the length 4 meter will give you RD, which is 5.389. it is positive in direction. So the other side will be of negative value, negative 5.389, right? So we have calculated this. Similarly, we can calculate how much is the reaction for this beam element. So I have calculated the reactions for beam element. This is for concentrated load, which is 60 kN, and it is at the center. So 30 is being substituted. Now according to the magnitude of end moments that we observed at MBC and MCB, we can calculate how much is the reaction. Okay, so once you solve this, the next thing is to identify these reactions, right? So calculating these reactions, what I would be doing, I would be taking the joint A. We will go at joint A, and at joint A we will try to determine how much is horizontal reaction, right? So to calculate the horizontal reaction, what I have to do here, I have to take the sum of the reaction that is observed from the point load. Okay, the sum of reaction that is observed by the concentrated load and the reaction that we have observed from the moment. Okay, I need to add these two at this joint. I'll get to know how much is my HA. Okay, once this is done, we can go to this joint, which is D joint, to calculate HD. To calculate HD, what we need to do, 0 plus of 3.389. so we have got how much is HD. Okay, now I'll come back to HC later. Let us calculate VA and VD. To calculate VA and VD, we must go to the beam member. Okay, now you try to understand here, because of beam member, okay, because of this beam member, the reactions that are developed over here, okay, they will be transferred axially over here as the reactions. Okay, so whatever the reaction that you get at these 2 points will be the reaction that will be distributed to as a vertical reaction at A and B joint. Okay, so now you take the sum of the reaction that you observed because of 60 kilonewton load and the end moments. So 30 plus of 3.334 will give you the vertical reaction. Now similarly 30 minus of 3.334 will give you the vertical reaction at D. Okay, as I explained you, the reactions that you observe here will get transmitted as a vertical reaction for joint A and joint D. So we have calculated VA and VD. What is the next step is to identify how much is HC. Okay, so to calculate the HC, what I should do is I have to add all the reactions that are observed from element AB and your CD. Okay, now see here, this is your element AB, 20 plus of 1.64, okay, plus of 0 plus of this value. Okay, what I should do to calculate HC? To calculate HC, I have to find out how much is the reaction that is observed here and how much is the reaction that is been observed by this element. Okay, because they act on the same line. Okay, so 20 plus of 1.64 minus of 5.389 will give you the horizontal reaction at C. Okay, this is how we have calculated the reactions. The next step is to determine the SFD and BMD. Okay, so to calculate the SFD, again going to joint A. At joint A, let us identify the shear force diagram for member AB. Okay, so at joint A, as you can see, in horizontal forces we consider this to be positive and this direction to be negative. I hope you remember this, right? So in this direction it is going 18.36, it means positive. So this reaction will continue till you reach the concentrated load. So 18.36 minus of 40 will give you minus 21.64, and this minus 21.64 will continue till this point. Okay, we'll come back to this later. Okay, now it will reach till 21.64. Next step is to go to next column, this column. Okay, how much is the horizontal force that is acting here, which is HD, and again this is positive and it will go up like this, and then as you can see there is no external force being acting, again it will reach to this point. Okay, coming to this beam member, to calculate the shear force for this beam member, what we need to do is to understand how much is the vertical reaction VD and VA. So according to this VD will supply the force to this, and it will actually create a force over here, and this force will create a shear force at this point. So this will be 33.34, which is equals to VA, and this will continue till you reach to the concentrated load, which is 60 kilonewton. So 33.334 minus 60 will give you 20 minus 26.667, and this will continue till this end, and as you reach the reaction over here. Okay, so the reaction at this point is D, so VD is how much? 26.67, so again it will become 0. Okay, this is how we draw the shear force diagram for this frame. Okay, now similarly going to BMD diagram, we already know how to draw the BMD diagram. First we draw the BMD diagram with respect to our external forces, considering it to be simply supported. Then we superimpose with the bending moment diagram of end moments, right? Okay, as you can see, this element, which is column element. Okay, now the one side is 17.81 and 24.37. like see, this is like this, this is like this. So this is a trapezoidal. Over that the triangular bending moment diagram is superimposed. Now similar to this one, again this is also remaining same. On this side, as you can see, this gets twisted like this, because as you can see the symbol is like this. This is going in this direction, again this is coming back in this direction. So we have to take this 14.37 in this direction, and we have to take this in this direction by 7.186, right? So like this you will draw the bending moment diagram also. Just to explain you the elastic curve I have drawn here. So what happens here is you have to write this as positive, this as negative. Okay, because of bending, okay, it will bend like this, so it means what, it will be positive in nature. So if it is bending like this, okay, we'll call this as negative. Okay, if you want to understand this, what I would do is that I'll take an example like this. Assume this to be column. Okay, I'm applying a moment like this, okay, at this joint, and at this joint I'm applying it like this. Okay, it is being twisted like this elastic curve will be like this. So it means what, this portion, top portion will be in sagging condition, and in the bottom of the column will be of hugging condition. So that's why this will be of negative in nature, this will be of positive in nature. Okay, I hope this is very much clear. We have drawn the shear force diagram, bending moment diagram, and everything. Okay, so if you have any doubt with this, you can ask me, you can message me, we can discuss about this later. Okay, thank you.